audible. Let's see. Yep. So I hope I'm audible. Let's see. Hello, 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 hello. Yep. So I hope I'm audible. Let's see. Hello, 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 hello. Yep. So I hope I'm audible. I think this might be better. Hello, 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 hello. Yep. So I hope I'm. I think this might be better. Hello, hello. Can you hear me? Hello, hello. Yep. So I hope I'm. I think this might be better. Hello, hello. Can you hear me? Hello, hello. Yep. So I hope I'm. I think this might be better. Hello, hello. Can you hear me? Hello, hello. Yep. So yeah, let's start. So basically today we'll be doing just for the fun sake of it, right? We'll be doing we try and explain object-oriented programming in JavaScript specifically, and I will also try and explain concepts like async, promise, await in JavaScript, and yeah. So that's what we're doing today, right? To start, I just hope everyone has if you're going to be following along or something, I hope everyone has something like Node.js running, right? So just use some online text editor, right? So let's call it we start with OP first, right? So start with object-oriented programming, right? Yeah. So when we talk about object-oriented programming, basically it's just a way of how can we represent stuffs in programming as a sort of object, right? In real life we have person, we have ball, we have houses, we have cars, we have students, we have, so these are like objects in the world, right? How can we bring it to the programming, right? So to be able to sort of conceptualize things as an object, I think it sort of makes sense, right? Because in real world it's everything is almost everything is a sort of object, right? So can we sort of bring that idea into programming? So it makes our life easier, apart from the fact that it has some other benefits, but I think it's more easier to sort of conceptualize wherever we are writing, right? We are trying to model programming in just like the word, just like the way of the world. We want to model programming in the way of the world, right? So it's basic. That's basically object programming. It's a paradigm, right? In programming we have multiple paradigms of of writing programs. One of them is OOP, obviously, object-oriented programming. We have functional programming. Yeah, we have functional programming. We also have procedural programming, right? So yeah, and different languages support different sort of patterns. Some languages support all of them. Some languages support maybe one or two. But most of the time, uh, most of the languages probably support it. But C, there is no OP in C. But obviously, there's a way that you can sort of do OP in C, right? Not like in the sense of OP, but like whatever OP can give, you can actually do it in C. But it's not like okay, this language has OP. For something like C++, it has OOP as part of it, right? For something like Java, it has OOP, and for something like JavaScript, it has object-oriented programming. But we have to understand that JavaScript, like when it was created, it doesn't really have object-oriented programming, and even now, it's object-oriented programming is not like object-oriented programming per se. It's more of like it's called prototypal inheritance, sort of, right? So basically, that is how it works. It's you can just call it prototypal, sort of inheritance, like it's so one interesting thing about JavaScript is that sometimes it doesn't have a feature, but they sort of build some way around it to have that feature. And before, it doesn't even have a class, right? These are like some things in OOP, but now it has classes, right? And but like that classes itself, it's not part of JavaScript, right? But with some softwares, that classes is being converted to like functional programming, which has the original inheritance stuff, right? So yeah, so that's a bit good introduction. That's a bit good introduction. And so when we talk of OOP, that, like as I said, we have like some features of OOP. We have like 4 major features of OOP, and we'll be writing it down. Encapsulation is one. We have abstraction, encapsulation, abstraction. You have inheritance, and and you have also polymorphism. So this is regardless of whatever language that you implemented OOP in, right? All languages that support OOP has all these 4 features, right? Encapsulation, abstraction, inheritance, and polymorphism. So these are like the four like features of OOP. Like when you're writing OOP programs, these are the things that you get, right? So I think starting from abstraction, right? It just, I mean, just like the word sound abstract, like it's sort of we are not. They just give us some interface, and we call that interface, and we're able to like do something with it. We don't need to know the implementation details, and even implementation details might change, but that's not our problem, right? That's not the problem that we have. So they just give us something, and we make all of that thing. So that's what abstraction is. Just think of something like when you do console.log in JavaScript, like it's console.log is doing a lot of things underneath, right? It's probably there is probably some calls to the operating system, they got to write something in the terminal, right? You can't so you understand. So the operating system making calls to the operating system also painting that on the terminal. So there is a lot of things that is being done along the line, right? There will also probably be some sort of passing or string formatting going on, right? If you are using format string. So, but we don't care about how those things work, right? We don't care about. They just give us the creator of JavaScript just give us okay. If you have console.log, you call console.log, you're able to use it like this. You're able to write something in the terminal, right? So that's what it's abstraction is going on. So that's just what abstraction is in programming itself, right? So, but I mean, in OOP, it's similar. Definitely, it's similar, but the syntax might be different, right? They just give you a sort of a class that okay, you can create a student class by year, but we don't care about the implementation details. When you create a student class with this, you have some features that okay, this student class can provide you, right? So, yeah, that is abstraction. Now, yeah, we have encapsulation. it's very simple. Like the idea of encapsulation is that, okay, you have a student class person. What are the characteristics of the person? What are the features of a person? Okay, a person can have an height, name, maybe age, all those things, right? So those are the data, right? Those are the features of the person. Those are data. But so there's also another part which are like actions or method. They call it method or actions, right? What can a student do, right? So a student can probably, maybe walk, maybe, talk or something like that, maybe make some noise, right? So if you look at the data, so the idea of encapsulation is that OOP, object oriented sort of programming, provide you with the ability to, like, couple together the data and those actions and those methods that, that an object can do, can right? So you have the the name of the student, and you have the make some noise, right? Which is something that a student can do, right? You have them coupled together, or something like do assignment and the name of the student, right? So in OOP, it sort of make it together. For something like, if you are writing something like, functional programming, you might have to, like, create, you might have to create the data differently. You might have to create age. Age is equal to, maybe you say age is equal to something, right? 34. You have to create another function called, maybe print age or something like that, right? Print age, which sort of, just, it might just take some age, and then it's just print that age, right? So this is like sort of like a sort of functional programming paradigm where everything is functional and stuff like that. But in something like, OOP, instead of having all these things differently, like, imagine if you have many functions and many data, they are not together. But in OOP, it's providing a way to, like, group them together. We see the example, right? So that's just encapsulation. Abstraction is, you give us one particular interface and we're able to use it. We don't care about the implementation details. Encapsulation is, you are bringing the data together, and the action that you can perform on the data, you are bringing it together in a point, right? So that's it. So then let's go to the next one. Let's go to the next one, which is called the inheritance. So when we talk about inheritance is like, we have a person, right? And there is also like a student, right? We have a person, we have a student, right? A student has some features, a person has some features, but every student is a person, right? So instead of, writing the same features in the student, no, you just inherit from the person. So the person already have age and name. So instead of writing for student, also writing age, name, and everything for student, you just inherit it from the person. And imagine you have something like animal, right? Animal is like sort of the big one. It has name, it has what it can do. So instead of having that, right, so you can have, like, something like goat, sheep, lion, everything, all these things inheriting from person. Just like, think like the way you are inheriting from your parent, right? You are inheriting maybe their face and all those things, right? So that's just inheritance. So we look more into it while we start, and we have something called polymorphism. So polymorphism, just like it starts, is like many form, right? Morphism is like form, right? So basically, when we say polymorphism is just having many sort of form, right? Imagine we have a sort of animal can make sound, right? But if you look at cow, if you look at sheep, if you look at goat, if you look at lion, they have different ways of making noise, right? So that's just polymorphism. Of course, they can make noise, but it's in different form, right? The way a lion is going to make noise is different from the way a goat is going to make noise, right? Yeah. So those are like the four things that we in OOP, and we sort of be talking about it while we move while we sort of move around. Yeah, so let's now take a look at OOP in JS. So when we talk about JavaScript, right, OOP in JavaScript, it's sort of implemented in three ways, right? And But you have to understand that OOP in JavaScript is just prototypal based. They call it prototypal based. It's not like the OOP like in in C++ and maybe Java. Right? Those ones are like sort of inbuilt. But OOP in JavaScript is sort of something that is implemented through prototypal OOP based, right? I'll be looking at it, right? So there are three ways of creating OOP in JavaScript. We have the normal class that that many people know. Class. We have class. We have the constructor function, and we also have the Object.create. So let's take a look at let's start from constructor function, because this is actually the way OOP is being firstly implemented in JavaScript before we have some other method, right? So yeah, so now we start from, let's say we have, so how do you create it, and how do you like model OOP based on through like construction function, and which is actually the prototypal base, this is like the way initially JavaScript OOP is being implemented in JavaScript. So let's say we want to model something like a person, right? Constant. So it's just like you are creating a function, right? Creating a function. Let's say you want to write, you want to create a person. So you are just creating it as like sort of function, and so what are the things that a person has, right? A person has let's say first name, right? First name, we have maybe second name, and we have and we have maybe birthday, right? Birthday. If you look at this particular so this is how you sort of create. So we can call this thing as a sort of like the class, right? This is the class. This is how you create the class. And we're talking of class. Class is like the blueprint. But yeah, I think it's quite hard to say blueprint, because I think in another language there is something that blueprint is another thing, right? But just think of it as a blueprint. Like, okay, if you model something, so how do you a person has a particular feature, right? So that is like sort of yes, when you see a person, I expected some things like maybe leg, eye, the person has a name and all those things, right? So that's a sort of blueprint, right? So this is so now like you can now create many objects, right? So now we have a class, we have a blueprint. We have a class and object. The class is actually the blueprint. How you create, a particular, how you create an example of it. So that example of it is called object, right? It's an instance of a class, right? So when you have something like Usman, different people, right? So Rajput and all those things, right? So that's like an instance of a class person, right? So how do you create an instance of a person, right? So you just say like Usman, you now use the keyword called new, right? So new, right? This is person, right? You just say new person, right? And when you say new person, what is it taking? It's taking, so this is why they call it constructor function, right? So taking first name, second name, and birthday. So let's pass first name and first Usman. Second name is and 2022. Yep. So interestingly, there is something that you need to know when you have something like new. When you're creating in JavaScript, when you have a keyword new person, so there is like something like 4 things that is actually going on, right? 4 things that is being done. The first thing is that number one, an empty object is being created. An empty object an empty object is created, right? So the second thing is that when a keyword called this, so a keyword called this keyword is also created, but it's now pointing to what the object above that was created, right? pointing to this particular object, right? So the next thing is so the object. So you just and I will explain this more. The prototype of this object is now being assigned, right, to the person dot prototype, right? Prototype. So basically, this person dot prototype is actually the one that allows, let's say we have many instances of an object of a person. You have like Usman, we have Arib, we have Fawaz, we have Rajput, we have Bharat and all those kind of names, right? So this particular prototype, that is part of like this person is actually what creates, it's the one that allows, each of these objects to share different, like to share method, to share the same action together, right? So this is we talk more about this, and there is also another one. We already said an object is created, a keyword. This is then the object is returned. The object is then returned. So now there is actually important why we say this, right? You create so when you write new, there is this keyword that is being created, right, and it's pointing to this particular object, right? So this makes it possible for us to do something like this. That okay, this dot first name is now equals to what? First name. This dot second name is equals to what? Second name, and this dot birth here is equals to what? Birth here. So basically now in JavaScript itself we have something we call object. Though this object is sort of different from this Usman object, right? But similar, right? But yeah, this one we are creating it through literal. This one is like we are creating it through like it's like an instance of a class, right? So this is also like an instance of a class. We can call it an instance of a class called object class. So now with this keyword, so when we say this is now what? It's now pointing to this particular empty object, right? So when we say this dot first name is equals to first name, right? So now it means that this particular object now has what? A member or a member called first name. So we say this dot first name is equals to first name, this dot second name is equals to second name, this dot birth here. So now, right? So this particular object now has all these four, right? So now let's say we now say Usman. So now after that the proto is the underscore proto is of Usman is pointed to like Usman of prototype, and the object is being returned. So this particular object with this dot first name, this dot second name, this dot birth here is now being returned to Usman. So if you say something like if you try to like console.log Usman.first name, you basically get yeah, you see we can get the first name, right? So that's the simple way to create an object, right? So now the next thing that we are going to talk about now is like right? So this is sort of like an abstraction going on, right? You just need to tell me that okay, if I do new person and I pass the first name, the second name, and the year, I'm able to get an object of Usman, an object of a person which has all these features, right? Right now, so the next thing we have to go to now is how can you create like an action, a method on a person, like how can you create an action on a person or on a class, right? How can you make an object to do something, right? So that's called method, right? So let's say they call it adding method to a class, right? So let's just come here. So we just bring it here. So this is done through this is what we call through prototypal inheritance. So what you basically do is that person dot prototype. So this dot let's say we want to be able to calculate age, So you just create, so this prototype, is a keyword that's part of the person, right? It's available for person, right? So it's an object itself. It's an object itself, right? You just add this particular calculate age function to it, right? So by doing this, because the Usman dot, if you come here, I said Usman dot underscore proto is pointing to this person dot proto. So definitely Usman underscore Usman object, we now have access to this calculate age, and it's been done through through prototypal chain lookup, right? So basically what happens is that when you do Usman dot, let's create this particular function. We just say this dot, we just maybe let's say it return 2026 minus this dot birth here, right? So let's say it return this, right? So this calculate age, this is what it does. So now if I now say, let's say cl Usman dot calculate age, if I try to run this, right, I will get the age, which is 24, right? When I get the age, so basically what you do Usman dot calculate age, this calculate age function, it's not in part of the Usman, right? So what happened is that there's something we call prototypal chain lookup, right? So what basically happened is that this calculate age will be we basically look for this calculate age, right? We look for it in underscore proto, right? So if we did not see it in Usman, we look for it in underscore proto, right? And then we look for it in so if you're not and this underscore proto is pointing to what? Person dot prototype, and we already declare it here, right? So it will work, right? So right, it is going to work, right? So that's how it works in in JavaScript, right? For constructor function, we can have something like we cannot say Rajput is equals to new person Rajput. So now automatically Rajput, will be created, all these things, will be initiated, this Rajput object. This Rajput object also will automatically have what? Will automatically ask the calculate, will automatically ask the calculate age function, which is the method of that object. Rajput.calc now Rajput is 21, right? So person.prototype.calculate age is here, the calculate age is added on the prototype. So when you create and I said when you write this new keyword, what is happening? This 14 is happening, and through prototypal chain lookup, you're able to find that okay, the calculate age is not on Rajput, right, but it's on his underscore proto, right? And if you look at because we can actually basically say Rajput dot calculate age itself, we can create the calculate age on Rajput directly. But the problem is if you create it directly on Rajput, it won't be available for Usman. How do we make it available? Through this proto, and from using prototypal chain in lookup, we're able to get the calculate age from proto, right? And if you want to be sure that this is actually that you can actually be sure that that Usman dot underscore proto is equals to person dot prototype. You can also do it for for Rajput also, and you see that it's true. And we can also say see Usman dot underscore proto is strictly equals to Rajput underscore proto, and you see that all of them are true, right? So you understand, right? So true, you understand. Now we can have like many methods, right? Many methods to this particular function. We can have main method to this particular function. So the idea of having sort of having the method, the actions together with the data is what we call we already talked about encapsulation. So yeah, it's what we call the encapsulation. You're able to encapsulate the data and the variable and the actions, the method. You're able to put it together at a point, right? So though this is not clean, but when we go to class, you will see that it's more cleaner, right? In class, it's more cleaner. Then yeah, so now before we move to inheritance, let's quickly look at how we can create all this particular this same similar way in class, right? So we say this dot first name is equal to first name, this dot second name is equal to second name, this dot birth year. So now, right? So this particular object now has all these four, right? So now let's say we now say Usman. So now after that yeah, let's come back. So for class, right? Class syntax. It's very simple and straightforward. So we can say okay. So you just ask class keyword person, instead of we can call it person class, right? And so in person we have something called constructor. Then you can say instead of here where we sort of put the first name, the second name here. So for class you can just, this is how you do it. You call the constructor second name, then you call the, so we can have birth here also, right? And you can now say this dot first name is equals to first name, this dot second name is equals to second name, and you can now say this dot birth here is equals to birth here, right? So this is basically it, right? Just like the way we do it here, right? Right, and the same when you write some, if I write let's say I say constant Usman's CL is equals to person new, so you have to use the keyword new person CL, right? And you now say Usman can you hear me? Then we now say 2002, right? So the same approach, right? So whatever is happening, when I said whenever we use the new keyword, this is what is happening. So it is also happening for this. And truthfully, this class is actually, it's just a synthetic, we call it synthetic sugar in JavaScript, right? It's not so like during the compilation process or interpretation process of JavaScript, this is actually being converted to this particular format, right? This particular format. But you see, this is more cleaner. You see why it's more cleaner? So we can have like the calculate age here. We can now say return 2026 minus this dot birth here. Can you see why it's more cleaner? We have everything. So this is how encapsulation looks like. Like we have everything together. Everything is together, right? It's easier like that, right? So, but yeah, it's sort of you have to. It's sort of scattered, right? Imagine you have many functions, right? So, but yeah, it's sort of you can have calculate age, you can have many other functions, right? And yeah, if you say cl dot Usman dot Usman cl dot let's say calculate, you're just saying calculate age, and let's print and see what happens. Oh yeah, you're right, you have the 24 year. You can see right. So yeah, you can see, and yeah, right? An interesting thing is that if you also do smart cl dot underscore underscore proto is equals to %cl dot prototype, you see that it's going to give through. So it's just like the same thing as it's just the same thing as the prototypal based constructor function based ways of creating classes in JavaScript, right? It's also true, right? So yeah, so that you see that's very straightforward. That's how you create that's how you create a person class in that's how you create a person class with class way in class way. So the third way, which I said, you can say Object.create way. This is less used, but yeah, it's also there. But it's important that we learn it before learning inheritance. So you can basically have like constant person. So its own format is sort of different in the fact that if you look at the class base and function base, we have to do person.prototype, right? This underscore proto is assigned to this person.prototype. But in object.create way, so what is actually happened? Let's put it here. So this it's actually been directly assigned to the prototype, like it's directly assigned to that prototype. It's not like there is no any intermediate like person.prototype. This is directly assigned to the prototype, right? So you can ask. So if you see what I'm trying to say, you can have an object which calculates age. As I said earlier, that this prototype person.prototype is actually an object, right? So you can have. So you now see that, okay, let's continue what I'm saying. You can say this dot. You can say 2026 minus this dot birth here. So right, so if I want to now create Usman, let's say I want to now create Usman, now we call it Usman object OC, object.create. It's now be what? Object.create, right? Person prototype. So there is no new keyword here. So what's basically happening is that if we now let's see, just Usman OC dot underscore proto is now equals to what? Is it equals to person. So can you see it here? So what's basically happening is that instead of having Usman underscore proto equals to person.prototype, it's direct. So this particular object is actually the prototype here, right? So this is more like straightforward, right? It's just assigning that proto to like the prototype itself. So you can have different, you can have another object. You can write Rajput, object.create person.prototype, right? You cannot have this particular way. Yeah, so you can have this particular way. Object have a particular function also called name that takes first name, second name, and birth here, and it basically just does the same thing, right? So sort of yeah, so it basically just does the same thing. And when you say Usman dot, you cannot just say Usman OC dot what dot init, right? So Usman then Akinyemi then 2022 or 202, right? And for output also you can see. So let me see if I can copy it from here. Yeah, and you can basically say, see here we can print Rajput, you can print let's say we want to print Rajput's age is equals to Rajput dot calc age, right? For Usman, you cannot say Usman. Okay, yeah. So I'll call it Rajput OC. Okay. Okay, yeah, so it should be returned. Right, so we cannot see, right? So, but yeah, if someone asks what is the difference between Object.create and and prototypal base, right? It's basically just the fact that this underscore proto, it's been assigned directly to the prototype, right? So that's basically it, right? Yeah. So now let's now go to inheritance, right? How do we do inheritance in the three of them? It's very straightforward. Let's see if the voice is okay, yeah, so it should be returned. Right, so we cannot see, right? So, but yeah, if someone asks what is the difference between Object.create and and prototypal base, right? It's basically just the fact that this underscore proto, it's been assigned directly to the prototype, right? So that's basically it, right? Yeah. So now let's now go to inheritance, right? How do we do inheritance in the three of them? Yeah, so basically if you want to do inheritance, right? So let's say we have a student class, right? We can call it for we start with what is it called? We start with the constructor function first. So let's say we have a student class. We want to have a student constructor function. It takes function first name, second name, and it takes course, right? So it takes course. So the question now is that student is just a person. Instead of us doing the same all these things that we have, all the things that we did here, right? We also probably want to calculate the age for students. can we sort of inherit everything from the person class? Yeah, we can do it. We can what? We can do it. So now, how do we do it? Very simple. So the idea is just that we just want to assign students dot, students dot prototype to equals to what? To the person prototype. But how do we do that? If you look at it, how do we? So basically, as I said, like, in a prototypal chain, there's a lookup that is going on. There's a lookup that is what? That is going on. So if, like, you are looking for calculate age on Usman. If Usman does not have it, Usman look for it under what? In the underscore proto, right? It also probably look for it. It keep looking it up, right? So it's going to get to the object, this particular object itself, which is the main, its proto is like none, right? So that's like the end. So it's going to keep looking it up. So now we need to assign, we need to assign, so there is a way that we assign this, when you say Usman underscore proto, it's what? It's this particular one, right? So how do we assign this, right? It's this particular one. So then if you now say student dot prototype dot underscore proto, so it has to connect to this what? This person prototype, right? It has to be something like, dot underscore proto to what? To person dot prototype. But how do we do this scenario that we want to assign this underscore proto to this prototype? So if you remember here, so when we are trying to, like, in Object.create, so we are trying to, like, assign this prototype object to this underscore proto, what do we do? We say object dot, so we say object dot create. So yeah, we remove this. So now the students dot prototype dot underscore proto will now be equals to what? This particular person dot prototype. So I think that it should be possible that you can say student dot prototype dot underscore proto to person dot prototype, right? Let's see. Let's ask ChatGPT, but I think it should be the same thing. Is this the same? It's the same idea, but like, does JavaScript allow it? Student dot prototype dot underscore proto is equals to what? Object dot is equals to person dot prototype. Leg is, maybe this is where it's been done. It's risky. So this is the cleaner inheritance. So yeah, so we can now, so it's better to just do it this way, but it's the same thing actually, because when you do student dot proto underscore proto, so we try to do something like this, right? CL dot is equals to person dot. You see that it's the same thing. Let's put CL here. Inheritance in prototypal phase. You see, it's true, right? But But yeah, this is the best way to create it, right? So what we did here now is that we already said, objects, we already assigned so now, like, we already linked the prototypal chain, right? That's, what I said. When you create Usman new person, if Usman does not have that particular calculate age, it looks it up in, Usman dot underscore proto. If that is not there, keep looking it up in underscore proto until it gets to, like, the object, the last point, which is the object, right? I think someone is knocking. Let's check whoever is there. Yeah. Walking. Meeting ना. मैं तो इतने में 5-10 मिनट लगेंगे बस. Meeting. I'm recording meeting. Baba, are they meeting now? Meeting now. Meeting work. नीचे बना रहा. Meeting work. फोटो खींच के डाल दो. फोटो खींच के डाल दो. Yeah, so let's resume. Where are we? Right. So yeah, object.create. Right. Yeah, so that is how you sort of link it up with the person. So if now, let's now create something like of a student. Let's say student 1 is equals to student. Are we done? No, not yet. So we have to, we have to initialize. We have to call this particular, person to help us to do this initialization. So that's why you said, you say person. So you use dot call here because when you say person, this keyword here, when you call person, you are not calling it through new. So this keyword is not being created. The object is not created, right? So you have to call this and assign this keyword from this particular, this point, right? You understand that, whenever I want to, like, create an object of an instance of person, we say new, but we are not using new here, right? So we have to, this keyword here will be, it will be undefined. So you have to pass this keyword that is in this student, we have to pass it here, right? Using the call. Then we say first name, that second name, and birth here. And we now say this dot course is equals to what? Course, right? By calling this particular person dot call, we already, it's going to make calls to this and assign all these wherever we have to assign, right? So if you have a student 1 who is whose name is Usman, or let's say STU, his name is STU, his surname is ENT, and age is 2008, and course is CSA. So if you now print, you can now print cl dot s1 dot first name, or you can print pp, you can print dot second name also, second name dot age, and yeah, you can also do the calculate age also. What is it? Cannot read the property of undefined first name. Wait, do we have to do this? Yep, so we didn't put new here. You see, that's what I said. So if you don't have the new, this keyword will not be set, right? So oh, so there is no age word bet here, right? So yeah, so we have it here, stood and bet here and age. So you also have to do this, right? You have to put the constructor dot prototype dot constructor to student, because this particular constructor is supposed to be pointed to student, but when you do inheritance through Object.create, right, in function in constructor function, this student is now pointed to this you know. So this student dot prototype dot constructor will now be pointing to person. But right, just know this, that you have to do this when you're creating the inheritance to prototypal base, right? Yep. So let's look at inheritance in what is it called? Inheritance in class base, or let's do, can we do prototypal base, the Object.create base? That is very straightforward. So that's very straightforward. You just have to do is so we just create a student proto, student prototype, right? Right, it also have init, right? First, it will have init, why? It's going to have init, right? And course, right? But yeah, instead of having this dot first name, so it's just going to make call to the first part, which is going to be person dot proto dot init dot call, right? It's going to call it with this, and with this, then first name, second name, birth year, and yeah, and then you can see this dot course, and we can now say we also have to, like, create the prototypal chain, student dot prototype. So the prototype of this, right, the dot prototype will now be linked to what? Object.create, right? Student dot person dot yep, right? Are we correct, right? So yeah, just like the way we sort of link it up here, that student person. But yeah, this does not need because this is already a prototype, so we just link it directly here. This is how we link it, right? So quite different from how we link it in constructor function, right? So let's try and see that we cannot see. So we cannot create student proto. Let's see student prototype cl dot student prototype object dot create based, right? And it's straightforward, and let's say this is group create, we have Async, age, we have, let's say, 1999, and we then have course, let's say Greek. So what you have to do, can we check, can we console.log cs st2 first name, second name also, and can we do calculate age, right? It should work because yeah. Assignment to constant variable. Is this the prototype? Wait. Let's ask. How do you link? This is what I'm saying. Let me give it to it. It's just saying shit. Oh, so there is a function. Okay. Okay, you can also use this scenario. Okay, instead of mutating it, or you can just make it let, right? It's correct, but yeah, you can just make it something like this. But yeah, I think it will probably be let, right? And then yeah, you can make it like this instead of, you know. Yeah, so we have group reads calculate age, right? So you just assign this prototype directly, right? So you can mutate it and you can just yeah. So yeah, then class is like the most straightforward one. How do you create inheritance in class? So let's bring the class. Let's bring the class here. So I will just comment out the other ones. Yeah, so we can have let's remove this. Let's say we want to add a student class which inherit from class the person class. You can just say student. We have to call the constructor also. Constructor, it also have first name, second name, but yeah, we have to put extends person class. Yeah, it extends the person class. So this is how you inherit using class way. Then you can do have a course here. So this, they provide a very good keyword for us here that you can now say super. So instead of saying person class dot call, so they just give us super. You can now call this and name and birth here. So person dot call student dot super. They first make calls to this particular constructor to create the person create all this, right? And then you can now say this dot course is equals to course. And maybe you want to do something, print course. right? It can also have its own, which basically just says here dot these dot scores, right? Yeah, and you can basically have a student constant st1. So let's just say Usman is a student. Usman is so you have to do new students here. New student Usman, and right, and you can also see it and CSCI, right? And you can basically, yeah. So you can basically then you can now say let's print it out. Yeah, it's going to have first name. You can now, it's also going to have calculate age, and yeah, and what's the problem? Strength has already been I didn't comment all this out. Yeah, so yeah, we are able to calculate the age and the span. So where is it getting the calculate age from person, right? So yeah, so there's also some other interesting thing that you can do with class, right? So there's something called getter and setter. So right, so we can do it, right? So get first name, which is going to just let's say it return so there is something similar in Java. You can say set first name. So he's going to take first name and he's going to he's going to say this dot first name is equals to first name. So the reason why we have this is that sometimes you might want to do some operations, right? You might want so before you sort of initialize first name, you might want to check is it a string. You might want to do some operations, right? So you can basically do it before the initialization. So when you say this dot first name, so whenever we now say something like when you're not saying Usman dot first name will not be forget it is going to be calling this particular function, right? So maybe you want to do some authentication that is this person authenticate? Is this particular class or is this particular is this particular object, is it authenticated to call the first name, right? Or right? If you also want to set it, right? So when you say whenever I say Usman, if I say Usman dot if I want to change my name, Usman dot first name, if I say it's equals to Ade, right? So it is going to be calling this particular first name, this particular this particular setter, right? So we get some error now. There's going to be some recursive call. I'm going to explain it, right? Why there is that recursive sort of call. So what is going to happen is that when we say new student here, right? New student is definitely making some call to this person class, right, through the extend and super, right? When you now say this dot first name, so what's going to happen is that this dot first name is going to be calling first name, right? It's because it has a setter method, and when it's called first name, inside it you have this dot first name again. This dot first name is also going to be calling first this particular setter. Then this will keep going on, right? So that's why there's a way that we do it. Just put something like this, right? Something like this, and this also is going to be something like this dot, right? But still we see, so basically this is going to be what the object actually has, what the person class has. But when you say this dot first name, it's not saying there is no actually an element that is called first name. So that this dot first name is going to be calling this setter method, right? It's going to be initializing this element, right, which is part of the person class, and it's going to be initializing it to the first name, right? So how do we can verify this is what I'm trying to say. If you log out Usman, You see that Usman does not have what? Usman does not have this, does not have first name. It has underscore first name, right? So it doesn't have first name, it has underscore first name, right? So when the constructor is trying to construct the this dot first name, it's making call to this particular setter method, which is first name, but that first name is not actually setting the, it's not actually setting first name, it's setting underscore first name. And the reason why it's not setting the first name is because of that recursive call which we got, right? So yeah, that is setters and get. And if you also want to, like, do setters, right? This is setters. So when we also print the getter, like as well as first name, this is like getter. So what you can do here, in the setter is that maybe you want to check, you can check first name dot what can we check is maybe is it a string, right? I think it's instance of something like a string, right? Instance of, if I'm not something like this. So you can check this. If not, you can say if something like if this is called, if not this, you can basically just throw an error. Oops. I think it's S. Let's see. So there is probably not. So how do you check? Yeah, so it's basically first name is instance of instance of string. Okay, yeah, so it's so what is the problem? One 57, 142, 142, 142, 166, and 175. Yeah, but is this not? Yeah. So what is oh, it's different. Wow, it's different. I don't even know. Primitive and object. So we should say we should say type of first name is equal to string, string, right? So this will compile now. Yeah, so yeah, that's getters and setters. So you can basically do operations before you set, right? If you set it directly, you'll be able to do those operations. So yeah, in recently now we have something called static method and static element, right? So basically, before moving, we have something called private we have private function, we have private function and private uh, element, right? So this dot first name, you can make it private by saying we can have something like a day. You can have this particular private name, no person. Let's say height. So this, you just put hash at the back, right? And if you are going to set it, maybe you say this. We can have a setter for that, right? Or we can have a setter for that. Let's say this dot height. It's called start 43. So we are just giving everything height, right? So if you try to like say Usman dot, if you're trying to get it, if you try to like get it outside of the class, yeah, it's going to be giving you error. So that's it's going to private field must be declared, so right. So you can't get height here, you can only get it inside the class. You can only get it inside the class. So you can basically have like a getter method, right? You can basically have a get height, and it's basically just return these dots, which here is, right? So if I say, you can now print right, and I can 43. So now you can also have like static method, right? Sorry, private method, right? You can have private method. Then you can also have static you can have static variable and static method. So basically static method is when we say static variable, let's say static so this is like something like, let's say species. So all persons are almost sapien. Right, so basically if you try to like right, so if you try to say Usman dot Usman dot what do they call it? Yeah, Usman dot species, there will be error because it's a static variable. Species Usman dot species. Wait, what is it saying? Is there no error? So it's saying undefined, right? It's not there, but we already said species is Homo sapien. So this when you say static, it means like you can only access it through the class. So they call it static variable. Sorry, class variable, right? While all these ones are like the object variable, but this one is a static variable, right? So you can also have the same. You can also have like these on functions. You can have it on private element, on private. You can have it on private. You can have static on private function, private variable, right? So what it's just saying is that you can only access this through. If I can only access this through by saying cl dot person dot species and u species, right? And it's going to it's get almost sapien. So you can have that for method and method also, right? So it's now going to be method of the class, not method of the object, because you can access it with the object. You can only access it through the class, right? By using the class name, right? So that is pretty much everything in class, right? So that's pretty much everything about classes. We can take a rest now, and when we come back, we can do async JavaScript, and we can do async JavaScript and maybe some promises, and yeah. So let's take about 10 minutes rest. So they just give us super. You can now call this and name and birth here. So person dot call student dot super. They yep. I think we should start the other part. So let's start about async await promises and in JS, right? Async slash sync and we try to write some promise and so how do we start? Let's start from here. So let's start from looking at what do we mean by synchronous and asynchronous. Synchronous is just it's just one. You're doing step by step, right? Step 1, step 2, step 3, you can think of it like that. It doesn't have to be like that, right? Like synchronous is something like, you know, when you get data from one, you're passing it to the other one, something like that, right? It's step by step, not necessarily step by step, because, you know, in programming generally, you could, you know, you could have at the bottom, you could have a function that is going back and calling another function from the top, right? So let's say you have, you know, function print name or something. Maybe this is not a good example. You know, if you look at it from the, you know, the assembly language sort of inner, you probably see that, you know, you have some jump, like, you know, from one part to another part of the code, right? But yeah, just think of it as something that is step by step, right? So right, it's like one thread, or you can just think of it as like, you know, maybe one CPU thread is the one that is doing the work. It's going from step 1, steps 2, step 3, step 4. You know, if it needs to jump, it jumps. So it's just one single thread doing one thing, right? And when you say thread is just a single unit of execution, right? When you write a program and you launch the program, you basically execute that program. So the single unit of that program, which has all the code, everything, is the thread, which has everything that it needs to execute. So that is what we call thread. You can have multiple thread, right? But yeah, it's just that single, like, it's just the simplest form of execution in such a way that, you know, it has you know, a program have access to all what it needs to execute, right? So just think of it like that. Okay, synchronous attacks that go from step 1, step 2, step 3. They jumps when they need to jump, right? When you are taking from it from assembly language, so they mostly jump during while loop. You know, it comes, it go back, it comes, it go back, or during for loop, or during, you know, function calling. Yeah, that's basically async. But for something like asynchronous, so basically, you know, before moving, we have something we called CPU tags. Basically, yeah, there are two types of CPU tags. There are two types of tags. We have the CPU tags and we have the, you know, IO sort of tags. So I think this is one of the things that sort of, you know, let's explain this first, right? So CPU is just something, you know, when you have to do operation, by when the CPU has to do some operations, right? 2 plus 2, you're adding something, you are, you know, accessing one particular data from somewhere. You know, when CPU has to, you know, accessing data from somewhere could it does not necessarily every time has to, don't let us say accessing data from somewhere, but like when you have to do some operations, you have to add something together, you have to multiply something together, right? That is like the CPU tax. Why IO tax is something, you know, you have to open a file, you have to send network requests, you have to, you know, so that is what we call IO tax, right? So basically IO tax are tax that is not being done by the CPU. The CPU does not do the IO tax. It actually, you know, the operating system is the one that is opening the file. You know, even when you're writing to your console, it's like an IO tax, and it's done by the operating system, right? It's more of you know, it's more of a kernel space stuff, right? So when we say something is async, let's say, you know, let's say it's something like, you know, asynchronous. You know, let's say, you know, you read it from a file. That is an example of asynchronous operations, right? When you read from a file, you basically tell the operating, you call a function and it's calling the operating system. The operating system now read from the file. The CPU is not the one that is working, right? At that point, it's the operating system. So that is asynchronous, right? So it's been done. It's the operating system that is doing it, right? So, you know, you make network requests to some, you know, you request for some data like through some API endpoint, right? Right, it's not the main CPU that you are using that is doing the task. You are sending the request to another like computer somewhere else, right? So, or even database request, right? Adapt database request. So, you know, you're in JavaScript. Just know in JavaScript that JavaScript is single threaded. Yeah, it's using single thread, right? So anything that doesn't when we say something like async, most of the thing. So if you are running a JavaScript program and it doesn't require you to use the main single thread, like the main thread that your program is running on, that's most probably async, right? That's most probably async. You have to do set timeout. When you do set timeout, like or you want to time out something, or you are setting interval, right? That's basically async in a way that you don't have to, like, it's so when you're doing something like set timeout, it's not this main single thread that is doing it. It's either the browser, right, or the runtime environment. Maybe it's JavaScript runtime, maybe it's Node runtime environment, right? It's like another thread that is doing it, right? So that's async. You have to make a network call to something. It's not this main thread that is doing the network call. It's just give it to some other thread to which makes it's that's like makes call to some other computer, right? So that does the work for it, right? It's through the operating system, right? So it's not the main single thread that is doing that task, right? So what is the other thing that we want to explain? Yeah, you get. So I think it's two things, right? When you're doing IO operations that require the operating system to do the work, that's async. Or when you're doing a task that does not that it's not the main thread that is doing the work, it's another thread, right? That is single threaded. So when you say runtime is basically where your JavaScript runs, right? Where your JavaScript programs runs. It's provided all the required necessary functions, necessary environments to basically run. So when you run a JavaScript on the browser, right, it's there is a particular JavaScript runtime that is running it, right? So and it gives access to many things. It gives your program access to many things, right? So for example, it allows it basically allows you to do set timeout and all those things, right? So those things are something that it's provided by the runtime, right? It allows you to read the file, it allows you to access some, maybe FS. When you are doing some library, so that's the environment. The environment is one that's providing you that, right? So, but there is a single thread that which your JavaScript code is running. While in that runtime environment, there will be multiple threads that is doing some work, right? But in that, in that particular, but your program is running using one single threaded. The environment is also running, doing some other thing, right? And so whenever you have a task that does not require your environment, your single thread, which is one that's running your JavaScript to do the work. So that's mostly what we call async, right? So for example, so when we say let's do something like let's print let's say step 1, I will say step 2, and we say step 3. What will you notice? You will notice that see this super everywhere. It's not this, right? You know that it's step by step. The main thread run the second line, then run the third line, right? So and they print it out step by step, right? That is a sync operation. Sorry, that is synchronous operation, obviously, because they are running step by step. But now let's look in a scenario, an example of asynchronous, right? Let's say you have something like set timeout, right? Which so after like a particular period of time, it's basically run something, it's do something, right? So let's say after 0 seconds, it's basically console.log step 2. Normally you will have think that step 1, then the next line is step 2, then the next line is step 3. No, it doesn't work like that, right? Because this particular set timeout is an asynchronous operations. So what basically happens is that step 1 runs. After step 1 runs, this run, but it's not doing the work. It gives it another thread or another part of the runtime environment to do the work. Then it run this. Then it now come back to this particular set timeout to see if something has. We will explain it more. So let's say we have like 10 seconds, right? So let's say we have 10 seconds here. So what basically happened is that no, this is 10 milliseconds. So this is probably 1 second. But yeah, let's say we have 1 second, right? Let's say we have 1 second. So what the main thread basically runs step 1. It look at step 2, it see that it's set timeout, so it give it another part of the runtime environment, right? It give it to another part of the runtime environment. The runtime environment, starts the timer. The timer keep running, then the main thread does not wait. You just go to the next line. It runs the next line. After running the next line, it's now, there's nothing to be run again. It's now come back to that particular, wherever it gives it to. It checks, brother, are you done with the work? If the after 1 second, if the work has been done, it's basically just run this, this step 2. So that's how you probably see step 1, step 3, and then step 2. So we try to run it. You see step 1 first, step 3, step 2. So you might say, okay, maybe because it's because of 1 second, right? It's because of 1 second, that's why it's waiting, right? So let's make it 0. Let's make it 0 and see. Let's make it 0. If you see still step 1, step 3, step 2, right? So because this is asynchronous, right? This one has it's so what's JavaScript main thread? You have to understand that main thread. I think if you understand the fact that main thread, it's if you understand that main thread, JavaScript has only one single thread, which is the main thread. So in a JavaScript environment, there are multiple threads, but the JavaScript that is running your program itself is just one single thread, right? So whenever it's running, if it look at this particular console.log, okay, it's run it. It's look at this set timeout to the main thread. It see that it has to do some timing, so it give it to another part of the runtime, which could be another thread, right? Another part of the runtime environment to sort of start the timing, right? And it doesn't wait for that; it just continue, right? It goes to the next step. So let's say there is 1 million step. It goes through the whole step. After going through all the whole step, so let's say maybe you also have another set timeout here. YPU. So if you have another set timeout here, so it comes here, it run it. Yeah, it see that I have to do some timing, so it give it to one particular part of the runtime that does the timing. It come back, it goes to the next line, it run it. Okay, there is no need for timing. It goes to the third line. I see that there is need for timing. It puts it back. So then after that, it now come back to like the first one. Okay, the timing is done. It prints it out. This one is also done. It's prints it out, right? So that's why if you look at this report, this is going to be right. So step 1 runs. Step 1 run. Let's look at it. So the step 1 run first. It comes here. Okay, this is set timeout. It's something has to do the timing. Give it to somewhere. It's put it somewhere, right? It run the steps. It come back to step 3. Okay, this is like a sync operation. This is a synchronous operation. It run it. Comes here. This is a sync operation. It give it. So after running all the line, it's now start checking all the sync operations. You see, okay, timeout. Okay, I need to I need to keep I need to the timing is already done. So it comes here, it's running because the timing is 0 seconds. It's running it, then it goes to the next set timeout. Okay, the timing is also done. It's run it, right? So let's say this is like 1 second. So what do you this is 100 milliseconds. What do you expect, right? So what basically happens is that it runs. The main thread comes to step 1, it run it, right? It goes to step 2, set timeout. It gives it to another part of the runtime. That one starts the 100 milliseconds. It comes here. It's running. It comes here also, right? So this is 0 milliseconds. So it means that it's give it to other part, right? But after running on the line, it's now go back to the part where it give the tags. Okay, that one will tell you. That one will tell you that it's already 0 seconds, right? It run this. It's already 0 seconds. So this gets run, but this is still counting the 100 milliseconds. It's now okay. It's still waiting. Then after that, it's see that okay, it's done. Then it's prints this, right? So that's just the simple way it works. But before we move forward, let's see like the visual representation of this. So there's a visual representation of what is actually happening, right? So So we can say JavaScript runtime. Let's see if there's a visual image online. Yeah, so we can look at this. Let's see if we can look at this. We will probably come to this, but let's look at this first. So if we look at this, that this particular part is a function, right? We call it callback function. Like, so what does callback means? It means that, okay, after this 10 seconds, after this 0 seconds or 100 seconds, you know, after this 100 milliseconds is done, like after the timer counted and it's 100 milliseconds, run this particular function. So this is what, so that particular function is called callback function. So basically, this is the JavaScript engine, which has the single thread, right? The call stack and the heap, they work hand in hand, and they are both in the JavaScript engine. The difference between it is that, you know, heap is where you allocate memory. Of course, you also allocate memory in stack, right? But something like, you know, objects, arrays, their memory is being allocated on the heap. While something like, you know, call stack, their memory is, where something like, you know, numbers, like basic data type, their memory is allocated on the stack, and, you know, the function are being stacked in the, you know, the function runs in the stack, and you know, whenever there's a need for allocation of memory, they run in the heap, right? But yeah, but you can just think of it as something that is single now. So basically, you know, when you have something like this, where's my particular so how can we make this better, bigger? So when you have something like this, right, this particular line of code, so let's explain it. So so this is the JavaScript runtime environment in the browser. It's provide, you know, DOM, all these DOM, fetch API, timers. Those are web APIs. So there's also the JavaScript engine, and there's also like the, you know, callback QE. This is also called macro tags queue. There's also another micro tags, but yeah, we'll look at it later. And this is event loop. This particular thing is event loop. So basically, what happens is, you know, JavaScript is running this. It's still console.log. Console.log runs on the call stack in the global execution context, but let's leave that. So, but it basically look at this console.log. It's in the stack that gets run. So when it comes to set timeout, so this is one single thread. This is the main thread. So what happens is that when you get to set timeout, it's basically like, you know, instead of running it, it doesn't have the timer. The web API is the one that have the timer. This is also running in another thread. This is the single main thread. So it gives this particular set timeout. It gives it to the web API to run. So the web API run the 10 seconds. It starts the timing. It run it. After running it, it's just this particular runtime. After, like, you know, 100 milliseconds pass, it puts, you know, this particular callback function. It puts it in the queue. That, okay, this thing is run. This thing is done. It puts it in the queue. But that, you understand, but this main loop, this single thread does not wait for, you know, it doesn't wait for the type web APIs to finish or whatever. So just give it to the web API, and it's continue its own work, right? So it's come back to the console.log. Okay, you see that, oh, I need to log something. It logs it. It come back to it, now reach the set timeout. When it gets to set timeout, you see that, oh, I need to, you know, it's just give it to the web API again, and the web API start the timer. So after that, so one thing, the way I sort of encode it is that this event loop particular part is part of the, you know, it's part of the main execution, like the main thread, right? So after running all the lines, so this event loop is not going to be doing anything until this single thread run all the line. After running all the line, it's will go back to this event loop, which is part of the JavaScript engine. So basically, the event loop is part of the main single thread, right? And it runs when it sees that, oh, there is no more tasks to do. So when it runs, so what it basically does is that it basically look into this callback queue, which is like first come first serve, right? So whatever comes first is going to be served. So it looks at this callback queue, and it see that, okay, this particular, okay, so this web API, what it's going to do is that it starts the timing. So if you see that 100 milliseconds is late, so it's like higher. So the timer will still continue, but after 0 milliseconds, that one is like immediately. So it puts the function, this particular callback function, arrow function, it basically puts it immediately into the callback queue. So this one will be the first one in the callback queue, while this 100 milliseconds timer is still running. So after that, this will be put in the what? In the callback queue. So making this particular step 4 to run before this particular step 2, right? So this is how basically it happens. So if you have multiple, like, multiple synchronous operations or multiple async operations, or multiple synchronous operations, and multiple async operations. So this is how the JavaScript runtime runs. So the single thread, go line by line, run it. So whenever it sees that, okay, this is something that it cannot handle, this has timer, or this is something like opening file, it cannot do it, it give it to the web APIs. So the web API do the tags, they put it in the so after they do the tags, maybe they have to, like, set on some timers. After the timers ended, they put it in the callback queue. So the JavaScript engine, the single thread in the JavaScript engine keep running. After it sees that, oh, I'm already done, I don't have anything to run again, right? So part of the JavaScript single thread, which is the event loop, now come to the callback queue and see that, okay, is there any, so all the things that I gave to web API, is it done, right? If it is done, so the web API, after it's done, it give it to the callback queue, then the callback queue run it, and it's give it to the callback queue. The event loop comes and see that, okay, on click is the first thing, it's run the whatever the callback function, it's run it, right? So I think this is probably much explanatory. If you look at this particular, yeah, if you look at this, right, so this is the call stack, and this is the heap memory. So console.log comes here, it run, set timeout comes here, right? So after the set timeout comes here, right, what basically happen is that the timing starts, right? After the timing is done, it puts it to the callback queue. After the event loop is done, after the main thread is done, so the main thread has the event loop, then the event loop start looking into the callback queue, and it starts working, and it starts like running wherever it's in the callback queue. So there's also like another queue called microtask queue. So anything that is called anything promise will be put. We have not done promise, but everything that is promise is inside the microtask queue, while others sort of promise is also asynchronous, while others sort of while other asynchronous, like set timeout, set interval, they are all in callback queue. But so anything that is promised is in the microtask queue. So that's basically what happened. So that's basically like async operations, and yeah. So let's continue and do some examples. It's already like let's take some few minutes rest, and we can come back.
I beg, make una dey check on them. Today making it 4 days now. I came back from France. Una well done. If you get person where they stay for France, I beg, make una dey check on them. Today making it 4 days now. I came back from France. When I came back here, seriously, Nana the sea road. People where they abroad, they will not tell you what I want to tell you now. They will not tell you this thing. No, come abroad, come abroad, come abroad, good, come abroad. That's why I take that money. I could book my flight with Windrew, and they really helped me to travel. When I go France, I visit France, na Europe. France not be Europe, oh. France na Africa. When I reach France, but all the
Okay, so what should we learn next? So now we are done with basic introduction to like Async, right? Let's try to read the file, right? We can just try and so reading a file is an async operations. But so I think JavaScript they provide a way that you can read the file synchronously. What do you mean by that? So this is the variable that this is the library that allows us to read a file. So we can now see constant content is equal surface dot read file. So you can read it asynchronously. The name of the file a.txt and well, the encoding, UTF-8 encoding, and yeah. So basically, this is how you read the file synchronously, like it run line by line, and you can basically print out the content. So let's see if you have a file called it.txt. Yeah, it's a file it.txt. So so if you try and run this particular code, we have okay, so this is the content, right? So this is the content of the file, right? So so exactly, that's how to read a file synchronously. But reading a file actually is an asynchronous operation, but JavaScript does provide a way to read it like synchronously. But like, let's try and read it asynchronously. UCC. So yeah, so we can now say so we just say first dot read a file. So when you read a file itself, without like read file sync, right? You know, it's read it synchronously. So we can e.txt. Of course, the encoding also, which is the UTF, the UTF-8, and you now have a callback function. So what this callback function is just saying is that, okay, after this reading this particular file, because if you have something like cl.lword, what's going to happen? So the JavaScript main single thread, that single thread will come here, run this and say that, oh, this is something that it cannot read the file. So it basically give it to it gives it to the the browser, the browser API, which we saw here. Where did you see it? It's basically to the browser API, yeah, the browser API to read the file, because the browser now through the operating system, the browser didn't read the content file. So that's synchronous. Sorry, that's asynchronous. So it's give it and it's continue, right? When it gets to this line, it run this line. So then it's the event loop now come back to the the tags, the callback queue, to come and look at what should it run. So basically what happened is that after reading this particular file, after the web API call the operating system to read the file, what does it put? So what does it basically put? It basically just puts this particular callback function in the callback queue, and that is what the event loop runs, right? So while putting it inside, it's basically pass this particular two variable, which is the error and the contents. So basically the error is like, you could call it value, you could call it anything, you could call this one also failure. So it's going to pass through variable to the function, to the callback function. So error, if there is an error reading the file, maybe the file does not exist. And content, what is the content of the file, right? So you understand. So basically it's gonna read the JavaScript single thread comes here on this particular line. It comes here, it see that, oh, this is a read file, it cannot do the read file. It gives it to the web API. The web API read, and then after giving it to the web API, it continue. It run this. Then what happened when it give it to the web API? The web API comes, read the file, and it now puts this particular function, which is the callback function. It puts it inside the callback queue after reading the file. So now it's now pass it to variable. So if this is not, if there is error reading the file, it pass the error variable, which is not undefined, right, or which is not empty, right? But if it fails, but if it's successful, it passed the content and the error is going to be undefined, right? You understand? So it passes to the function and puts the function in the callback queue. Then after the main thread run everything, then its event will now come back to this particular callback queue, and it's now called this particular function, right? Just give me a minute, I want to check something. Let's see. Let's see the two apps. Oops. Okay. Yeah, so let's continue. So inside this callback function, we can now do something, right? We can now say, okay, if there is an error, if there is error present, we can print the error. We can just print the error. Or else, if there is no error, just cl, we just print the content of the okay, it's called content. So if you understand, so what do you expect, right? Obviously, this is going to run. This is given to the web API, which read the file. After reading the file is present. It puts the content here. This is going to be our undefined, right? And then it's basically just run and puts the function inside the callback queue. After the the main thread run everything, it basically look at the callback queue and see that it's something is there. So and it's look at it and it's look at this function. This is undefined. It's look at this line and basically just run it, right? So that's why we have hello world, which is what is here running first, then the content of the file. If you look at the content of the file, so you see that this is the content of the file. So let's sure you understand. So that's basically read file. So but this is reading it asynchronously. Yeah, while the read file sync is forcing it to read it synchronously. And let's say the file is not present, right? So let's remove the file. So there's going to be an error, right? I already removed it. Right, so it's printing out the error, right? No such file or directory. So yeah, now let's move basically to promise. Let's move towards promise. So there's two things that we need to learn about promise. How many hours have we used? So there's two things we need to learn about promise. We need to learn about two things about promise. We need to learn about consuming a promise, and the two is writing a promise. Consuming a promise and writing a promise. Yeah, so I will write a promise. Don't worry about writing a promise. Then we can consume it together. But after that, we learn how to write a promise. We learn how to write a promise, right? So let's say we want to we just write the promise constant. We just So promise is an object, is a class, right? There is a class promise which is provided to us by JavaScript, right? So it basically takes in a function. So this function you could put an arrow function, or you could put an arrow function, or what is it called? An arrow function, or function declaration. So the new promise object takes two function and takes the new two function, takes one single function and pass another two function into it, which is the promise and the reject. But don't worry too much about this. We will discuss more about it. We can say, okay. So we can just resolve this after after many seconds. So we will look at it, what this is, but yeah. So how do we consume a promise? That's what we want to learn. But yeah, so now what is promise? Yeah, promise is I promise you something. Yeah, I think that's like the simplest way to think about promise. Right? You promise something, you promise someone something, and I think there are three scenarios of of a situation of a promise. If you promise someone something, there are like three scenarios of the situation of a promise. One scenario is that let's say I promise someone I promise someone money like after 2 months. Like, okay, the next 2 months I'm going to give you some particular amount of money. So it means that that promise is still pending, right? I've not been able to the promise is still pending. I have not actually it's not yet for me. It's not yet the time for me to give the person the money. So that's like the state of the promise. So pending, and the other one is after 2 months, then we can have after 2 months, it's either I'm able to fulfill my promise, or I just failed at I'm not able to fulfill my promise, right? That's basically that's just the idea, right? Either it's pending, the time is not yet up, or the time is up, I'm able to fulfill the promise, right? I gave the person the money, or failed, I didn't give the person the money. So this is in JavaScript, this is also called pending, right? This is also called fulfilled. Yeah, and this is also called fulfilled, or it has been resolved. Or this is also called failed. You can also call it failed, or it has been rejected. Right? So these are the cases. These are the cases of of promise. Now, so this set time out, I promisify it, but yeah. So let's see what I'm trying to say. But before we can move on, we can basically say yeah, let's call this promise.promisify. I will just, it's a function, right? So if I say set time out promisify, if I give it 10 seconds, I'm telling it to after 10 seconds, you will see what's going to happen. So what's going to happen is so it's pending, because it's immediately I log it, it's pending, right? So what basically happened is that the single threaded comes, run it, and it's this particular set timeout promisify, you see it's returning a new promise, right? So that promise cannot be in multiple situations. It could be resolved, it could be fulfilled, or pending, right? So but because 42 milliseconds have not passed, so, or because the main thread just gives someone to it basically gives this particular part. It comes here, this is the promise, and it's give it to the to this microtask queue. This particular, it's called, first give it to the web API, right? After it gives it to the web API, because we are logging it, so it's what is the situation of the promise? It's pending, so it's log it, And so this particular part, try to like resolve it. After it's resolved, if it fails, it puts the callback function. It puts it in the promise, promise queue, right? The event loop first look at the promise before the callback came. Just keep note of that, right? So this is just the idea of fail to fulfill, or it's not failed. So let's put something like 0 seconds. Yeah, because this log it directly, so it's gonna be something like that, right? So it's still pending because the event loop quickly just it's just put it in the web, the API, the web API, and it's go back and it's just log it, which is still pending. The web API has not resolved it at that point. It logs it, right? So, but now how can we wait for it to be resolved? Like, how can we wait for this promise, right? So there is a promise, there is an object of promise, right? How can we wait for it to either failed or or be successful? So that's what they call consuming a promise, right? How do we consume a promise, right? So it's very simple. We can now say, so we basically call this particular function, which basically return the new promise, right? This is the one that is returning the new promise, right? And then we basically just call the then. So don't just note that this is just like a promise. It's returning a promise. That's just what you need to know. Don't care about that, the complexity of how it works. We talk about it, but just know that this is a promise. It does something. It's return a promise, right? So how do you consume a promise? Dot then. So you can basically say dot then. CL hello dot then. So this then takes a function val. So if it is successful, it's just do this callback function, right? So we can say hello world, right? So we can console.log hello world. That if it is successful, console.log what hello world, and it's going to say hello world. So it's waiting for it, right? But when it fails, you can now say dot catch. So that's where the catch comes in. Okay, it also take another function, which is the error, right? It takes and then you can try and CL the error or something. But yeah, this is probably not going to fail, right? So because the way we write it, so right, and this is basically how to consume a promise. If it's passed, so if the promise is successful, do this. If it fails, do this. So when you try to do a fetch request, right? So the fetch request is going to return a promise, right? So now you cannot consume the promise. How do you consume the promise? You do dot then. You are going to do dot then, right? When you do dot then, so you're going to pass this particular function. That okay, if it fails, if it passes, so takes whatever the output of the dot then, have the value and log it. If it fails, the error is being passed to the callback function, and it's what, and you basically log it, right? So let's try another scenario for when we have something like for a file. If you have a file, so let's promisify. I will write I won't explain how to write it. I want to promisify read of file. Read of file is asynchronous. Promise is also asynchronous, but it's not promisified, so it means we can't consume it like this. So let's try to promisify the file, the reading of file, right? But yeah, I won't explain how to read it. I will explain that later. So I want to show you that it's possible that reading of a promise can fail. What happens, So I will just write it. Don't care about how I write it. I will explain that later. So let's say set read file or let's just call it read file promisify. So it's a function which basically just read it basically just read that file. So it has to return a new promise. It's always a new promise, and that promise is going to take two so like the promise class is going to pass, it's going to take it's going to take a callback function. Why taking a callback function? Is so whenever it's sending a callback function to this particular microtags queue, it passed these two functions to it: the resolve and the resolve and the reject function. And then we can now see inside this we can now say fs.readFile so now we can take the name of the file here. Don't worry, I will explain it to you. File encoding there now. File name encoding and yeah, it also take another function of error comma value. So readFile takes three variables, sorry. So if reject the promise with the error, so don't care about how just know that okay, readFile is going to be a promise, right? It's a promise form of reading a file. So now let's call the readFile promisify, which basically just take a file name. What is the file name? a.txt and it's the file name a.txt and it's basically just call the encoding, which is UTF-8 and yeah. So if you try to log this particular readFile, it's just going to be a pending promise, right? Because okay, there might be some error somewhere. Yeah, there is error somewhere. Okay, this is a function, right? So yeah, okay, another error. Okay, fs is not defined, so let's define fs constant. So yeah, so readFile promise, return a new file. Reject the file. Okay. So what does readFile takes? Yep. So this was supposed to it's consoling the error, but wait, limit.txt. Let's run it again. read file console.log read file dot promisify read file dot promisify. Okay. Yeah, exactly. So when we try to if you try to console this thing, you try to run it, try to, so it's pending, right? So how do we consume it? Promise is pending, right? So how do we consume it, right? So that's when we are going to do dot, the way we do it upward, dot then so then is for if it's pass. So basically when dot then is going to pass this particular, the value of, so if the promise is successful, so this value which is in the resolve will be passed to this particular, function, the then the callback function that you put in the then, right? So you cannot do it, you cannot log the content of the, the val, but in case it failed, you can do catch, right? And I think you should understand what will be in the cache wherever you pass to the, to the reject, right? If it fails, right? So you cannot do cell dot error, right? So if you try to do it, right, so basically just know that, for you to if you have a promise, that's why, when you use something like fetch, when you do fetch something, the link of the, maybe https dot dot https dot like this, I don't even know, www.google.com, you basically just, say dot then, right? So if it is successful, you pass a cover function, and let's see, let's try it now. Right, so if it is successful, you it's a value will be passed, then you can print out the cl.val, right? Cl.val. If not, if it fails, you can do catch, right? And you can now see, you also pass a function, and you can basically say that, so an error will also be passed to it, right? Error variable, and you can basically say cell.error, right? And let's try it out and see. Right, so this is the content of when we do get, right? We get this particular, so this is successful, right? So then this is, this value is being logged here, right? It's called this particular then method. But let's say we omit something like this. This is probably gonna fail. This is going to fail, right? So okay, it's saying it's passed, but this is google.com. Is there google.cm? Let's see. Yeah, so this fail, right? There is nothing, so it fails, and then it's basically called this particular catch, and there is something called finally, which, it will, whether it fails or pass, it is always running, right? It's you can now see, just say finally. You see, whether it fails or not, there is always finally, right? So this is how to consume, right? This is how to consume a promise. So this fetch API basically just, this fetch API return a promise, just like the way we are returning the promise here, right? And how do you consume it? So if it's pass, if the promise resolved, this particular method is being called. If it fails, this particular method is being called, and the value of the value so basically it's actually the value of the resolve that is being that will be passed. The value of the resolve is what will be passed to this particular value. That is what you are going to have access to, and the value of the failure is what, if it fails, is going to be for the catch. And finally, if you want to do, if you basically want to, finally, it will work whether you sort of, whether you finally is going to work whether it fails or not. So now let's now go to like callback L. There's something they call callback L or something like that, right? So I will use this particular timeout. Let's say you want to you want to print out step 1 after 1 second, step 2 after 2 seconds, step 3 after 5 seconds. How do we do it? We say set timeout, right? We say after 1 seconds, we can say console.log step 1, right? Then we're now going to say, okay, set another timeout to right. Then that's going to be what, after 3 seconds. So that is going to be 2000, right? Because 4 seconds is going to run first, then this one. Right, so you can now say CL step 2, and we can now say set timeout again after 2 seconds. We can now say CL step 2. So imagine when you have to do multiple, something like this. Sometimes you have to do a lot of fetch, and imagine it will probably just keep going like this, right? So that's what we call, you start noticing that pattern. That's what we call that's what we call what is in English? That is what we called callback L, right? It's going to work, but this is callback L, right? Step 1, after step 2, then step 3, right? Is this up to like 1, 2? Yeah, I think it's up to 5 seconds. So now how do we solve this callback L? So this is basically where we have promisify. Like this is one of the function of promisify, right? So how can we do this with this set timeout promisify that we have? So we could basically say, okay, set timeout promisify, we pass the seconds, which is 100 seconds, then then, right, which is going to be CL step 1, right, after this, then we can also now say, okay, return you set timeout, right, of 2000. So we're basically returning a set timeout promisify, but this is going to return a promise, which you can then also put another then there, right? CL step 2, and then dot then. So we also return it again. Then we can now say dot then. You can now say CL step 3. So even no matter how long it has to be, it will keep going in a straight line, right? And it's more readable, right? But for something like this, it's sort of harder to read, even not because I had step 1, step 2, step 3. That's when it's step 1, step 3. Assuming it's something else, it will be harder to read, right? But here it's always going straight forward, like in a straight line, right? If we so this is how you solve a callback callback L with promise, right? And then you could basically say step 1. Okay, let's just comment this out, and yeah. So step 1 this, then step 2 this, then step 3 this, right? So this makes it looks no. So when they ask why do we use promise instead of something like just using the set timeout itself, which is not promisified, but both of them are sync, but one is promisified, one is not. So one of the reason is it's more readable, and it's just also like solve all these callback L that we have, right? So this that. So now there is also another better way, there's also another smoother way of doing this. That's where async and await comes in. Async and await async, and one thing you should note that async and await is for promise, not. So just note that all promise are async, but not all async are promise, right? Set timeouts with set timeouts like this. We are doing set timeouts like this, the way we are doing it earlier, like this one, right? It's just asynchronous. It's not promisify. So you can't use async and await for it, right? Set interval, you can't use async and await. But immediately you promisify it, you can then use what async. You cannot use async and await. So async and await just makes our life easier, So now let's do this similar thing with async and await, So you just have to put it in a function. Async, you can just call it resolve, or print resolve. You can call it resolve promise, right? So inside it, we can have so one interesting thing is that you can have constant press 1, or we can just await them because they are not returning any value. Await set promisify 10 seconds. So this is going to be 1000. This is going to be 2000 and another 2000. And you can see YY, you can come here, see p1, p2, and p3. One, I can see 1, 2, and then 3. So we can now call this particular resource promise. Something has been wrong here. Yep. So let's let's comment this out. So step 1, step 2, accept. So you see that even if you ask, let's say we do console.log hello world, you put it here. So what do you think we run first? Right, what do you think we run first? Obviously, so this is still like async, right? So what's going to happen is that the main thread will come here, it's async, it's gonna it's async, you see that it's async, so it's going to enter into the async. It's see that okay, this is awaiting a promise. A promise is an async, so it's basically put it in the promise, in the promise, in the tags, in this particular this particular set to promise queue, right? It's put it there. It comes here also, it puts it there, it comes here, it puts it there, then it goes to the next line which is not in the promise, then it's the single thread basically just put it out. It basically run this immediately, and then after seeing that okay, there is no more left, no more left, what is it called, no more left things to call, right? It's now come back to the through the event loop. It's now looking into the settled promise. It you see that okay, the first one is resolved, it run it. The second one is resolved, it run it. Third one resolved, it run it, right? So if there is anything inside the callback queue also, it run that also, right? So yeah, so you see this is probably like more beautiful and then this way, right? So to make it more clearer, let's start to like let's start to like read the content of a file 3 times, right? We will use the then way and the async await way, right? So let's say so we have this method readFile promisify, which read file. So you can say readFile promisify, it takes a.txt and then the encoding. So how do we resolve it? We call .then on it and it gives us a function, and we basically do something like this. Writer. So this gives us the when the then is called, it gives us the content of the file, right, which is the sources. So we can now say okay, cl.file, but maybe you can now say return right. You can actually then again and function called content cl content, and then say the same thing that yyp3. You see, this is going to come, read the file one time, log it, return a read file promise, which is basically, it's reading a promise. It's returning a promise, then you can resolve the promise. It's there. This is also returning the promise and there. And you can have a catch here, which catch if there is an error. And then yep, you can log the error or something. So let's try and run this. That was fast. Is there any error? Yep. So it's come here, it's run it, come here, read the promisify file, pass the file, read the file, the web API puts this callback into the promise queue, which is the microtask queue. Then puts the value after reading the file. This log it. This also create another promise, return another promise. This also resolve it, run the content, run the output, return another file, and this also return it. But this is too too complex. How do we read it? It's async. So you can say sync function. We can call it 3 times. We just basically say it's very simple. Just say const content, wherever the content is, just await read file promisify it.txt, and then etf minus 8, and then you basically say ypp, and if you want to log it, you basically cont yypp. So you basically so as I said earlier, lads, async await is asynchronous, as I said. So if you have any other thing that is not asynchronous, that will be run first before this, right? It's just a better way of writing this, right? So what is the problem? So we are not calling it, right? We should call it. So we should call this function 3 times. It's L-word. The same thing, right? So that is how so but if you are going to consume a promise, so this is the best way to consume a promise. Right, you can't use this for set timeout, right? Set timeout is not a promise unless you promisify it, right? So I think the question now is, how do we write promise? How do we promisify an async function? How do we promisify an async function? Right. One thing to note is that whatever async function return is always a promise. right? So if async returns something, it's a promise. How do we know that? Let's say we return 5, return now. So if you now say dot then function content, and you see cl content, right? You see that it's a. So whatever async return, it's always a promise also. So you can use this method of then, or you can put this 3 times inside another async function, right? Yeah, how do we write an async function? I will try to make justice for it. I try to make justice for it, and then yeah. So these are the 2 async functions that we have, right? So by just taking a look, I will just take a look at it. We can explain through the, and so it's just very simple. When you want to write an async, you want to promisify a function. You want to promisify a function, right? So what you basically just do is that you have this set timeout, which is an async function. So as I said, a promise can either be resolved or rejected, or it's still in pending state, right? So depending is when you create a promise, it's just in pending state. So but you have to be the one to when you're writing promise, you have to be the one to either resolve it or reject it, right? So you can either resolve it, or you can either or you can either reject it, right? So when you promisify something, it means you are returning a promise, right? So whoever is now calling it has to resolve it with either the then or catch, or the async and await ways, right? So basically if so basically you have to return a new promise, and inside that promise you have to either resolve or reject, right? So when you resolve it, resolve is a function that is that the promise class will pass, that we resolve and reject is a 2 function that the promise class is going to pass to the to the callback function which you put here, right? So when you say dot then, so it means that it's successful, right? And you pass a callback function which take a variable. So whatever the content of this, if you whatever the content of the resolved function is what's going to be passed here, and whatever the failure, if it's failed, so that's what's going to be passed into the into the dot catch, right? So now we are not saying okay, return a new promise, set timeout, right? So what's going to happen is that this is going to be a new promise, and set timeout is going to take a particular milliseconds. Let's say after 10 seconds. So and don't forget that set timeout is also taking a it's taking a callback function. So now you can now pass this resolve function. So what you're saying is that after set timeout run for a particular seconds, right? Resolve, right? Just call the resolve function, but you are not passing any variable to it, right? So you're not passing any variable to it. So that's why it's going to it's not going to the then. We look at when we are trying to call the then for set timeout set timeout. So the then is not taking any variable, right? So but let's look at this particular readFile promisify, right? So it's so you are basically returning a new promise. So when you read a file, right? So if there is an error, you reject with that error, right? It's just very simple. If there is an error, you reject with the error. If it pass, you reject. If it's able to read the file, reject with the with the value, right? So it's just simple as that. You create a new promise, but inside the promise you either have to reject or resolve, right? So how do you know when to reject? So you might just reject only or resolve only. So when you resolve, you are going to when you resolve, it means that you are able to read the file. So you pass a value, so you resolve it, and when you reject, it pass the error. And when you're trying to like just when you're trying to use the then when you're trying to use the then on it, right? So automatically whatever the content of the resolve is, if it's passed, will be passed to the the callback function in the then, and automatically it's going to be passed to the if it fails, it's going to pass to the cache cache here, right? So if you look at the three times, right? So this content, this whatever this read file is going to be returning, is going to be this away. It's going to be the it's going to be the value in the result, right? How do we get the value in the if it is rejected? So that's when we have. So let's come back here. So let's comment this out. So let's comment these two out. Let's remove this then. So now instead of doing all this, let's remove this return. So you have to do it in try and catch. Okay, 1, 2, 3, 4. So it's basically 6. You put it here, right? So the error is going to be you can print out the error. And there is also like a finally block, just like the way we have it in then also, right? You can now print the finally we always print. Right, so if you look at this, right, if you look at this, so if it's pass, if it gets resolved successfully, that result value will be put inside this content, right? Wherever you pass into the if you look at this particular promisify result value, the value here, which is the content of the file, will be the one that is in this content. But if it fails, it is going to be this particular error, right? It's going to be passed to the error while finally we always run. So yeah, I think the last thing that you probably need to know is we have let's say you have multiple promises and you want to sort of return it. How do you? There are like some ways that you can do it. We have promise.any, promise.raise, promise.all settled, promise dot and promise.all. So this all of them, they take like array of promise. And they also return different stuff for something like race, right? So this basically return. So if you have multiple promise, it's basically return the first promise that resolve. The first promise that is fulfilled. What should we say? The first promise to either fail or resolved, right? Whatever promise that first to either fail or resolved, right? It returns that. So if any of the promise first is the one that is first successful, it returns that. If it is one that is first first that fails, it returns that. But for something like all settles, it waits for all the promises, whether any one of them fail, whether any one of them pass. It's wait for all of them and return all of them, right? For something like promise.all, this either return, so all of them have to pass. But if all of them does not pass, if one of them fail, so it's returned back. It's returned immediately, like it returned whatever fails. While promise.any, this is waiting for the first to pass, right? So if one fails, it doesn't matter. So it's waiting for the first to pass, right? So yeah, I think we're going to be ending the course there today, right? I'm going to probably just stop this, and the remaining 40 minutes I will just do it in a different stream. So I'll probably just call this, I'll just name it it's a course, right? So I'm going to just upload it, right? Let's let's do something. I will tell ChatGPT to create a sort of content for it, right? sort of something I can upload in